Question 9 of our June paper 2 for grade 12 this term was our second question on Euclidean geometry. The first question was a proof. I'm not going to go through a proof with you, they're always the same. You need to study them. Okay, so in this diagram, O is the center. When you see center, your brain should be thinking of things like radii, right? These and these, they're both radii. The other thing you should be thinking of as center is angle at center 2 times angle at circumference. This is an angle of center, right? Or angle at the center. Then these are points in the circle, KT, those are chords. Chords should be letting you think of if a line from the center bisects a chord, then you have a 90, and vice versa. Those are drawn, it intersects there, tangent. Okay, and they're telling you specifically this one is a tangent. When you see the word tangent, your brain should be thinking radii and tangents are perpendicular. Actually, I think the reason is the other way around. I think it's tan perpendicular to radii. Anyway, you should be thinking of tans from the same point. Okay, there's only one tangent, so this one is actually irrelevant. And then the other ones you should be thinking of is tan chord theorem. And then they're telling you this angle over here, the whole angle is 36, and this angle over there is 18. Okay, so everything is indicated nicely for us on this sketch. Okay, then let's go look. They want to know the size of T2, which is this angle over here. So now firstly, we did the first thing you should be thinking of is then earlier we said radii should be letting you think of something. And we have a tangent, and actually that's where the radii and the tangent meet. So obviously this is perpendicular. So then T2 would be 90 minus that 36 degrees you have over there, which is 54, and your reason would be tan perpendicular to radii. Then we're looking for the value of L, which is this angle over here. Okay, it's in this triangle. We don't know anything about those sizes. But do you notice this angle over here? If you follow this chord to close it, it's this one. So in other words, this would also be 36 degrees. And your reason would be tan chord theorem. Yeah, remember the angle between a tangent and a chord is equal to the opposite interior angle. Then we're looking for KOT, which is this angle here at the center. We already found the angle at the circumference, so this one must be 2 times that one. Okay, and I know it's the longest reason we have, but you have to write them out. Okay, you can write circumference fully if you want to, but yeah, you need to write out the reason. You could have also got another way to find that this is 72. You could have found, okay, we know this angle is 54, which would make this one also 54, because angles opposite equal radii. And then you can use interior angles or triangle. And now we are going to prove that these two sides are equal in length. So if you go look at it, they are asking you to prove that this side and this side is equal in length. Okay, so this is not a story about an isosceles triangle because this is a straight line, which is what should be reminding you of what we said earlier about the relationship between a chord and a line from the center. Okay, so if you can prove that any of those angles are 90, that would make those two sides equal. So we need to find out that one of those are 90, and then we can go from there. So the easiest would be in this small triangle over here. If we can find that M, which is KMO. So you get the size is 90, and this is interior angles of a triangle, or you can say sum of angles in triangle or angle sum of triangle. Now we have that this is a 90-degree angle. So because this is 90, those are equal. That KM and ML are equal, and your reason is because the line from the center is perpendicular to the chord. Okay, not bisects the chord. Bisects the chord is a reason for why they are perpendicular. The thing that you are proving is not on the reason, okay? The reason is what you have that makes that true. Okay. You could have also, of course, decided you would rather want to go find this angle over here, okay, by knowing this whole angle is 54, angles opposite equals sides, radii. Then you would have gotten this angle. And then once you have this, you could have also used interior angles of a triangle in this triangle. Either way, you should have gotten a 90 and therefore the bisect part.